So, I know it's like emotional whiplash with the quiz. Here we go. So, order of operations with exponents. We've done order of operations. I think this will be the 5th time we've looked at order of operations. Now, order of operations comes from how all of these, and some of you, that has been a frustration for you. You're like, why is this the order? I don't want to just accept it. I want to know why. Now, the reason why this is the order is because of how we built all of these different operators. Everything's like the most fundamental math that we've looked at is addition and subtraction. Now, when I'm adding and subtracting a whole bunch of the same thing, we decided that multiplication was going to be a way to handle that. Instead of adding together 2 plus 2 plus 2 plus 2 plus 2, 2 plus 2 plus 2 plus 2 plus 2, 5 of them, people who became early mathematicians said, you know what? Let us invent notation to deal with this. Okay, well, if I have 2 plus 2 plus 2 plus 2 plus 2, that's 5 2's. So we can develop multiplication and say, okay, well, 5 times 2 means I'm adding 5 2's together, which of course is going to be 2 times 5 is 10. Multiplication and division are the same thing. Division is just multiplication by a fraction. And so division just gets looped in there as well. We say, okay, multiplication and division are the same thing. But because these things are based on repeated versions of these things, they have to happen before this happens. So because addition and subtraction are condensed into multiplication, these guys have to happen before any of the other addition or subtraction gets tacked on at the end. So if some of you have expressed a frustration as to why this happens, this is why. Now exponents we've talked about where these guys came from. Exponents are just repeated multiplication. Multiplication was repeated addition. Exponents are just repeated multiplication. If I've written this thing as x to the power of y, if I change this and I say, well, this is just 2 to the power of 5 now, what that means is I've got 2 times 2 times 2 times 2 times 2, 5 of them, which is 32. Now, because this is repeated multiplication, we have to make sure we get it out of the way before we multiply anything else onto that, which we have to get out of the way before we add anything else onto that. And that's just because of where it came from. It's repeated multiplication. It needs to get dealt with earlier. And now brackets, for those of us who are frustrated with this, brackets has to happen absolutely first because brackets were designed to isolate portions of, Ethan, wake up, portions of equations away from other things. Brackets were literally designed to say, this thing needs to happen first. Whatever is in this box needs to get dealt with. That is the definition of what a bracket is. And so because of how all of this was developed and for the meaning of this bracket here, this is the order that this needs to happen in. It's not arbitrary, it's very intentional, and it has everything to do with how these things were built. Everything is related to the fact that addition and subtraction came first, and these are just built on other versions of later operations. So I don't know if that helps, but again, some of you have expressed frustration with, why do I do it in this order? And that's why. If you didn't want a history lesson, well, I'm sorry. Then that was the history lesson. That was the history lesson. So let's do a couple examples. Recall now, BEDMAS, we're going to bring in the E. The E is here. E stands for exponents. Exponents look like this. I've got some base to a superscripted number. Superscript just means it's raised. This to the power of this means this thing, the x, gets multiplied together this many times. Now, some of you might be like, okay, well, why is the root in there? This is the square root symbol. We're going to look at roots later in this chapter. It'll be the last thing that we look at in this chapter. Roots are the opposite of exponents. Exponents say multiply this thing together this many times. Roots say how many times do I have had, or what do I have to multiply together this many times to get the number that's inside. So because it's just like division and multiplication. These guys are opposites of each other. Exponents and roots are the opposite of each other, so they get lumped together in BEDMAS as well. Let's do a couple of these examples, and we're just going to apply the exponent laws and the meaning of exponents to this to solve some fairly simple equations. And then we've got a whole host of practice. So, I got this bad boy here. I'm going to write BEDMAS so that it's on the screen. You get a calculator for this. Now, the thing I do not want to see is for you guys to just ram this thing through your calculator, because your calculators will do this for you. I want you to demonstrate that you understand the order here, and so you need to write that out as we go. So, if I have 5 plus 3 squared and I've got a set of brackets there, what needs to happen first? Well, Jared and Sahil. Jared, I was giving Sahil crap for getting involved with you before. Now, why are you getting involved with him? Jared, leave Sahil's stuff alone. Brackets happen first. For each one of these questions, let's follow BEDMAS. Brackets happen first. Is there any math outside the brackets? No. So do these brackets even need to be there? No. So this question could have easily just been written like this: 5 plus 3 squared. This and this are the same thing. Because there's no brackets outside, they don't actually need to be there. So now we move on to the next piece, exponents. Exponents is, well, I've got one right there. So then this piece needs to get dealt with first. 3 squared is?
6 plus 9.
Careful. 3 squared means 3 times 3. This thing here means 3 times 3. If you have a calculator with you, and I told you to get one, if you recall, using these calculators go like this. If you're like, okay, I don't remember what 3 squared is, so I'm going to use my notation on the calculator. This one looks like this. I push the 3. This one has the box notation. Some of you will have the arrows. It opens up, looks like that. 3 squared is 9. So as you're showing me the work, this is what I want to see. I want to see that you know the order in which these things need to go. Yes, Ethan? When I'm done, a couple examples you may go. Because I want you following these examples because you've expressed frustration with not being able to do these things. So I want you to stay. That's why I'm trying to work it through with you. So no, you may not use the washer. And then the last piece, 5 plus 9 is? 14. And we're done. And I won't, if you don't take the notes down here with me, I won't let you use the washroom either. And that's how you're going to get yourself signed up for PAC. Mentally. Nope. Mentally is not going to fly. Okay, let's do the next one. Okay, I have 3 squared plus 3 squared. They're in brackets. Do I even need to have those brackets there? No, because there's no math on the outside. So let's do this thing. It's going to become 3 squared plus 3 squared. What has to happen first? The exponent. So 3 squared is 3 times 3? 9 plus. So, and again, this is how I want you to show me your work. Break it down piece by piece. Show me what's happening here. It's not 16, Sahil. 9 plus 9 is also not 19. It's 18. And again, you do have calculators available to you to do the simple operations one at a time. If you follow BEDMAS, it's not going to be, you'll be fine. It's not overly, not super tricky. Okay, second one. Third one. Second row. I've got a set of brackets here. I've got a minus sign on the outside. I've got a squared right there plus 5 squared. Now this one brings in a little bit of trickiness because if you recall way back, like a week and a half ago when we started exponents, I tried to go out of my way to really kind of hammer home this idea of what happens with minus signs, which I'm assuming we forgot. Now, a negative sign out front like this, what this means is I've got a -1 there. If there is no number written, it's a 1, and when it's just a minus sign, it's a -1. What this means is I have a -1 times 3 squared. And then plus the 5 squared after that. This is what that minus sign means. That minus sign means I'm multiplying by -1. And now BEDMAS is still going to follow. I do have brackets, but there's nothing going on inside. It's just the number 3. Nobody cares about just the number 3. So let's move to the next. But there's nothing to do with the number 3. 3 is an important number. It's true. So we move on to exponents. Now, the reason I'm separating it out like this is because now, if you're going to punch this into your calculator, the mistake that I see all the time is that people say, okay, well, I've got -3 and I'm squaring that. You're not. We're just squaring what's immediately next to it. So that's just the 3. So we can do it in our heads, or we can punch it into through a calculator. 3 squared is 9. And I'm still multiplying by that -1. This piece here is the only thing that we've done here. We've got -1 now times 9. That's what that minus sign up front means. Now I've got another exponent further down. So if we wanted to, you could actually deal with this thing at the same time as we dealt with the 3. Because we can do all of the exponent stuff together. 5 squared is?
25.
Careful. To square something means to multiply it by itself, which you're welcome to use a calculator for. 5 times 5 is 25, as a whole bunch of you have said. 5 plus 5 is 10. 5 times 5 is 25. You have multiplication tables that I've given you 1,000 times. You could have them in front of you right now if you wanted. You've all got calculators I told you to grab. Use the tools.
I am a calculator.
So now the next step is to do what? Look at what we've got written here. I've got -1 times 9 plus 25. BEDMAS says, okay, that's a lot of signing. Either sit up and take notes with me, or this is where we're going to start signing people up for PAC. Well, that is an easy problem to deal with. Have we looked for the book in the backpack?
Yeah.
Okay, then I will get you a copy, right? Here you go. Have a seat. Sit up. You are at least a little bit responsible for your own learning. Okay, so BEDMAS has happened. We've done the brackets. We've done the exponents. There is no division. Now we multiply. What are we multiplying? Well, a -1 times 9. -1 times 9 is? -9. So I'm going to just get a -9 plus 25 here. You are welcome to use a calculator for this. I'll show you how to use your calculator for this. It is not 3K. Get a calculator in front of you here. It's also not 34. Okay, guys, negatives. You got to be real sure that you're about your negative addition and subtraction if you're not going to use a calculator. It is in fact 16. And let me show you how to use your Dakota. That's what you were going to say too. I appreciated the hand up. I want to show you how to use the calculator for it. Now, these calculators have minus signs in multiple spots. I've got a minus sign right here, and I've got minus signs over here. This top one's actually supposed to be division, but the dots are wiped off. Okay, everyone looking up here. When you've got a question like this says -9. On the calculators that you're going to borrow from me, if you want to make a number negative, you have to use this button here. So we're going to push the negative and the 9, and it's going to look like this. Oops, nope. We're going to push the negative and the 9, and it's going to look like that. If I'd use the subtraction button, it would look like this. And it's going to give me an error. Oh, no, if I had minus 9 minus 25. Oh, this calculators actually do it. Some calculators give you an error when you do that. So negative 9 plus now, what's the number? 25.
24.
25. 16. If your calculator gives you an error when you try to do that, you're using the wrong minus sign. Another way to think about this, we could swap the order on this. It's the same as 25 minus 9. You got to be really careful. Some of you guys are starting to rush ahead. Be like, I know this, and then you get it wrong. Number 10. Page 10. Be real deliberate about how we do this. Try not to rush. Okay, this one is... You're not in a rush. I give you so much time. There's no rushing. This one is different. The question looks very similar. The only difference here now is the minus sign is inside the bracket. When the minus sign shows up inside a bracket, what that means is the base is negative. The negative is a part of the things that we're multiplying. So what this thing right here means, this thing is negative 3 times negative 3. Now, if you punch this into a calculator, you need to punch it into the calculator exactly as it's written. So you have to put the bracket first. Then you've got to put the negative 3 first. Then you've got to put the closing bracket, and now we're going to square that thing. If you're going to use a calculator for it, you have to write it out exactly as it's written, otherwise your calculator is going to do something different. Negative 3 times negative 3, a negative times a negative is a positive. 3 times 3 is 9. So what we're going to get here is 9 plus, and we can do the 5 squared right away. We just did it. 5 times 5 is 25. And now you can see here, we've done the brackets, we've done the exponents. There is no division, multiplication. Now we just add them up. 9 plus 25, yes, as Garrett has said, this is 34. Cool business. We'll do a couple more and then I'll free you to play. Bedmath says we do brackets first. Is there math going on inside the brackets? Yes. As Garrett and Dakota both said. There's addition and there's multiplication going on inside the brackets. So what has to happen first? The multiplication has to happen because the multiplication is repeated addition. We need to get it out of the way. So 2 times 3 is 6. So the way you're showing your work is you're writing, okay, this is 2 plus this piece here is 6. And I've got that thing squared on the outside. Now, I would like to show you a mistake that I see students make all the time. The danger with showing you a mistake is that all that you remember is the mistake, and then you start making the mistake when you wouldn't have before. Bedmath says what is supposed to happen first. Here now. I've got 2 plus 6, and I've got an exponent on the outside. The brackets are still here. So we need to finish the work that's inside the brackets. 2 plus 6 is 8, and that squared stays on the outside, and then we can do the squared. 8 squared is 8 times 8, which is 64. So that's what I see students, this is what I want students to do. I desire students to do this. This is what I see. This is a mistake. Write the word mistake. Write the words do not do this. And I want you to pay attention really closely to what I'm about to do. Do not do this. If you're not paying attention, this is what you're going to start to do. Don't do what I'm going to put in the box here. What I see students do, actually one of you who shall remain nameless just modeled this. It wasn't you. This person said, well, I've got something inside the set of brackets here and I've got an exponent outside. So what they try to do is they try, students everywhere, try to bring this exponent in. Remember, the exponent law only exists when you're multiplying inside the brackets. But students try to do this when we're adding. Students will say, this is 2 squared plus 6 squared. This is bad. This is wrong. Do not do this. The exponent laws only hold when you're multiplying. And we're not multiplying here, we're adding. Okay? Be really careful to avoid that kind of mistake. When you're adding inside brackets, you need to actually do that addition first. If you do it this way, I'm not even going to write this down so as to not confuse people, I'll just say it. 2 squared is 4, 6 squared is 36. If you do it this way, you're going to get the answer of 40. BEDMAS says, though, the answer is 64, and we follow BEDMAS because of, again, where all of the operations came from. Sorry? Reese's. As long as there's no nut allergies, the Reese's are okay. Okay, we're cool with what I've done here? Okay, do a couple more examples. You know what, maybe I should, we'll do a couple more examples and let you play. Okay, what are we doing in here? I'll leave it to you guys. Talk to me. What's happening first? Brackets need to happen. I have 2 sets of brackets. So I've got a set of brackets on the outside and then a set of brackets on the inside. So let's go all the way in there. Okay, inside these brackets, what's happening first? Yes. Specifically, so what did you do first there, Garrett? What did you do first?
As we were doing, we haven't done this, but have we?
What did you do? That's okay. You're doing great.
3 with the exponent of 0 is going to 1.
So you did the exponents first. Anything to the power of 0 is 1, and because that minus sign's not inside a set of brackets here, it's not included in it. So we're just going to go 3 to the 0 is 1. And then this is going to become 1 minus 1 inside those brackets. We still have the times 5 out front. I still have the 2 to the 0 plus out back. I want you guys to model your work, Hassan, the way I model my work. I'm changing 1 or 2 things at a time and I'm working down the page. So inside those brackets, we had an exponent, we applied the exponent, and now we're going to do the subtraction inside those brackets. 1 minus 1 is? 1 minus 1 is? 0. I still have the times 5 out back. I still have a plus. I could do this 2 to the 0 right away. 2 to the 0 is? 1, because anything to the power of 0 is 1. And now I've got 1 plus 0 times 5. What needs to happen first here? Yep, if you recall BEDMAS, we're at multiplication stage. So 0 times 5 is 0. And then 1 plus 0 is?
5.
Don't screw people up on purpose, Garrett. 1 plus 0 is? 1. Liam? Okay, I'll bring in everyone's favorite number. Here we go, fractions. I did. Okay, you know what? I'm going to save the fractions. We'll skip the fractions. We'll come back to fractions tomorrow after the quiz. Yes, Ethan. You want to do this one? If you do this question for us, I'll let you go to the washroom.
Oh my God, Ethan!
Let's do it.
So,
Ethan, what happens first?
the 4, if we mix 4, the 2 times 2.
Oh, so you're applying the exponents. Very good. 2 squared is 2 times 2, which is 4. Very good. So we're going to apply all of the exponents first.
Now it's 6,
Almost.
7, 8.
8. There you go.
And then now I'm... Wait, so it times itself times
Nope. 3 times 3 is?
9.
And 3 times 3 is?
9.
And 9 times 9 is?
81.
There it is.
Do that.
So that's how I would break up 3 to the 4. I would say 3 to the 4 is 3 times 3 times 3 times 3. These two are going to make 9. These two are going to make 9, and then I can multiply 9 by 9.
Oh.
That's if you insist on doing things in your head, which lots of you are starting to insist upon, that's the trick I would use to do 3 to the power 4. And then divide by 3 squared is not 6, it's 3 times 3, which is 9.
Oh.
And now this thing is awful. We're just going to march it through here. 4 times 8 is 32.
Times 81.
Times 81 divided by 9, and this is where you're going to pull out your calculator. What is the result here?
Go look at these.
Get a calculator, Garrett. I told you right at the beginning. Dakota, what'd you get? Try that one more time. Wait, did you do all of it? Have you done the division by 9? Okay, now divide that number by 9. When you have a string, or you've got a line here that's just multiplication and division, you can do all of this in your calculator at once.
Am I good?
As soon as we get an answer to this question.
Okay,
Dakota, there you go.
Now I'm good to go.
Now, Ethan, you may use the washroom. Okay, so that was me doing a bunch of examples of this kind of stuff. I would like you to play with some of these things. I'll save the fractions to tomorrow. All I want you guys to do is A through H. I got 8 questions. Take a look at that stuff. We'll save the exponent law quiz till tomorrow when I have you guys last block. When he comes back, it'll probably be lunchtime. No, once you do these questions. No, you cannot take the quiz home. Okay, use this time. You have 8 questions, and you can get this done in 10 minutes. Let me help you if you need it. Try it. On your mark, it said giver. Just these first 8.
You can take it on your